Okay, so on Thursday's lesson, I handed out a worksheet for you with a couple of pedigree questions for you to attempt to see how you do. And so if you haven't yet attempted them, I would encourage you to give it a go on your own first, and then watch this video to check to see how you did. So let's read through the question. So the question says, make a pedigree for left-handedness using the information of the Thomas family. So it says the father Tom and mother Diane have 3 children. The oldest child is Anna, then Mary, and then the youngest child is Teddy. The oldest daughter, Anna, is married and has an older son, Will, and a younger daughter, Vanessa. Okay, lots to unpack here. Mary is also married and has a son, Patrick. Teddy is not yet married. Everyone in this family is right-handed except for the father, the oldest daughter, and the granddaughter. Right-handedness is dominant. Okay. So I'm going to start with some symbols here. So first of all, I am going to do a symbol for Father Tom. And then I'm going to show that he is married by doing that dash, Mother Diane. So to show that it's a female, I'm going to draw a circle. And so now it says the oldest child is Anna. So, and they have 3 children. So I'm going to kind of create a big long thing here because I'm not sure how much room I'm going to need. And I'm going to show Anna. And then I'm going to, and she is married. So I'm going to show her as married. And has an older son, Will. Older son, Will. And daughter, Vanessa. There we go. Mary is the second child. So let's draw Mary. So here is Mary. And Mary is married and has a son, Patrick. And so we'll draw there's Patrick. And then Teddy is not yet married. So I don't know. Teddy could be a female or a male. So let's just do a diamond. If you decided that Teddy was male or female and you put a different symbol, that's fine. To me, it's a little bit ambiguous, so I'm going to be safe and just put a diamond there. Everyone in this family is right-handed. And so right-handed is dominant, remember? And so everyone is right-handed. Makes sense that the majority of people would be right-handed, except for the father. So I'm going to go ahead and fill in for the father, Tom. The oldest daughter. So here's my eldest daughter, Anna. And the granddaughter. So here's our granddaughter. And if we wanted to, we could kind of make some guesses about the genotypes of these individuals, right? So, let's just do that just for kicks. And so if I know right-handed is dominant, and we're going to assume this is autosomal dominant, then I'm going to use little r for my left-handed person. And, over here, this granddaughter or this daughter has to be little r, and then little r. So the only way that daughter and granddaughter get 2 little r's, 2 of the recessive genes, is if mom over here is heterozygous for right-handedness, so big R, little r. So I'm hoping that you were able to identify those pieces, or if you didn't think about it, that maybe hopefully that makes sense as we're talking about it today. And make sure you reach out if you're struggling with this in any way or you need any help. Let's take a look at the next question. Okay, so in this next question, we're talking about albinism. So albinism is a trait where you lack melanin, which means that your skin will be pretty pale, your hair will be pretty pale, your eyes sometimes have a bit of a red tinge to it. And it is autosomal recessive. Okay, So use D to represent the allele for normal skin and DD to represent the genotype for albinism. Okay, fill in the genotypes below for each individual pedigree. So I'm hoping that those that are afflicted are pretty easy, and this is autosomal, it's not sex linked, so we're gonna put little d, 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 little d. And now we kind of can go backwards to figure out the genotypes of parents in a similar way to what we did in the last case. So when I look at my little d here, that means both parents had to contribute the alleles, the little d allele for that trait. Otherwise, there would be no albinism. So that tells me right off the bat that both mom and dad, in this case, have to be heterozygous. Otherwise, there's no getting the little d, little d. Now, and so the same is going to have to be true of this dad right over here. It's going to have to be big D, little d, because in order for the daughter to have two little d's, one has to be coming from each parent. And then I can extend that to other questions here. If, of course, this particular individual is little d, that means each parent had to contribute a little d. Oops. My screen's being a little wonky here. I'm not sure why. So both of these parents are going to have to be heterozygous for the condition because of course, they're not expressing it. So they both have to be big D, little d. Now, it's tough to say what this individual's genotype would be because they're not showing any children, no offspring. So we have actually two options here. This could be big D, or it could be big D, little d. Both of those are possible. And without looking at any offspring and the possibility of albinism there, it's really hard to tell which. So we're going to put both down. Okay, and so I would say in the case of this particular child right here, the only possible genotype is the heterozygous genotype. And I'm going to tell you why. The reason is that they're getting the big D, the dominant allele from dad, and they're getting the other allele from mom. And all mom has are these little d, the recessive allele, to contribute to that genotype. So that individual has to be heterozygous for the trait. I hope that that made sense. And even if you got it wrong, that me going over it makes sense to you. If not, feel free to reach out for some additional clarification, and I'll be happy to go through it with you additionally.